Today let's cover 7.5, which talks about a geometric series and a specific type of geometric series, an infinite geometric series. Here's an example of an infinite geometric series written in summation notation. Before we go ahead and actually calculate what this sum is equal to, let's write out, expand, and sort of understand exactly what it is we're doing. And so this again is sigma, which means sum, which means add up all these things. Start when k is equal to 0, end when k hits infinity. And so these are the values. This would be a geometric sequence, a sequence because it's just a list of them. And now to make them a geometric series, we add up the sequence. If we flash back to 7.4, we had a formula for adding up the k terms of a sequence. What would happen if we set k equal to infinity? So the first number is still the same. That doesn't change. That's still n sub 1. But what happens if k is equal to infinity? Let's make this s sub infinity equals n sub 1. So n sub 1 stays the same. But what would happen if we took infinity? So one question is, what is r equal to? So if we go back over here, in this case, what is our r? It's 1/4, right? So in this case, r is equal to 1/4. So what would happen if you took 1/4 to the power of infinity? Well, that's going to be 1 to the infinity divided by 4 to the infinity. Now, what's 1 to the infinity power? 1 times 1 times 1 times 1 times 1 times 1? It's 1. Okay? What is 4 to the infinity power? Let's just say 4 to the infinity is pretty close to infinity. Now, what is 1 divided by infinity? 1 divided by a really big number. And if you think about it, write this out. Well, we kind of did it here. 1 to 1/4 to 1/16 to 1/64 to 1/256. As we keep raising these powers higher and higher, this number is getting closer and closer to 0. So what this means is that r to the k power, as k goes to infinity, this guy here approaches 0 with our common ratio of 1/4. 1 minus 0 is 1, and so this just becomes 1 divided by 1 minus r. Or you could write the whole thing in one shot as n sub 1 divided by 1 minus r. And that is the sum of an infinite geometric series. So here's the geometric series that we just described. 1 plus 1/4 plus 1/16 plus 1/64, so on and so forth. And we want to add all this up. So we would say the infinite sum is equal to n sub 1 divided by 1 minus r. So what is our first term? 1. So we'll put a 1 in there. Divided by 1 minus r. So what is r? What is our common ratio? And you already said it was 1/4. Let's pretend we don't know what's 1/4. So how can we figure it out? Well, you would say, what do you multiply this number by to get a 1? And then what do you multiply this number by to get a 4? Yep, so this is times 1 times 4. And then you could repeat that. What do you multiply this by? Times 1. What do you multiply this by? Times 4. So r is equal to 1/4. So we're going to put a 1/4 in here. So that becomes 1 divided by 1 minus 1/4. So 1 minus 1/4, you could probably do this in your head, 3/4. If you can't do it in your head, then what you're going to want to do is you're going to convert this 1 into a 4/4. And 4/4 minus 1/4, so 1 divided by 3/4. I don't like doing 1 divided by 3/4. My brain would prefer that you multiplied by the reciprocal. So it becomes 1 times the reciprocal of 3/4, which is 4/3. And so this sum is 4/3. So here's another one. S sub infinity is equal to n sub 1 over 1 minus r. And so all we really need to do is determine what is our first term and what is r. So the first term is pretty easy. You look at the first number in the sequence and you got it, 3. All right, and now what about this common ratio? So if we make this 3/1, you kind of play the same game. You say, well, what do you multiply 3 by to get that? And what do you multiply 1 by to get that? So it's going to be 12/7. And if you go to the next step, just to make sure you did it right, this times 12 is 432, and this times 7 is that. There is one thing. So instead of multiplying by just plain old 12, we're going to multiply by negative 12. So in this case, r is negative 12 sevenths. Let's plug them into the formula. So 3 divided by 1 minus negative 12 sevenths. 1 plus 12 sevenths, you're going to convert this 1 into 7 sevenths, and you're going to add that to 12 sevenths to get 19 sevenths. So we get 21 over 19. And that is what the sum is, 21/19. So find the infinite sum of the geometric sequence. A is equal to 4, r is equal to 4 sevenths. So again, you're pretty much just plugging this into the formula, n sub 1 divided by 1 minus r. So this is 28 thirds. But I can see you still might be skeptical. I'm getting a feeling like you're like, come on, is this really the formula? All right, so let's do one that we know. Let me give you a decimal. So 0.4444, repeating forever. So if I take 4 and I divide it by 9, look what I get, 0.4 repeating. If I take 2 and divide it by 9, look what I get, 2 repeating. I think by using the calculator, I've sort of convinced you that this is equal to 4/9. 4 divided by 9. But I'd like to show you another way I can prove to you this is equal to 4/9 by using an infinite sum. This decimal here, you would say that's equal to 4/10, right? Plus this number, which is 4/100, plus the next number, which is 4/1000, plus the next number, which is 4/10,000. Continue this out to infinity. So this is taking a decimal and rewriting it as an infinite series. 4/10 plus 4/100 plus 4,000, blah, 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 blah. Okay? So we just need to know two things to figure out the sum of this infinite series. We need to know the first term, and we need to know what our common ratio is. So what's the first term? 4/10. 4/10 divided by 1 minus the common ratio. What's our common ratio? What do I multiply 4 by to get 4? 1. And what do I multiply 10 by to get 100? 10. So our common ratio is 1/10. And our initial value is 4/10. So we take those two values, we plug them into our formula, and now we have to do some arithmetic. 4/10 times 10/9. And when you multiply these two, the 10s cancel, and what are you left with? 4/9. Still not convinced? 0.9999, repeating forever. Is that equal to 1? And this gets back to our discussion we had earlier, where you're like, is that really that number? Come on, like way out there, way out in infinity. There's still got to be a little bit of a gap, so that way it's not exactly equal to. So this is my question. Is this true? True or false? 0.999 repeating forever is equal to 1.
If you round it.
No, no rounding. Straight up, as is. You're saying this is not equal to 1. You sure? So we're going to take this decimal and we're going to rewrite it. We're going to write this decimal as an infinite geometric series. So this first 9 is 9/10 plus the second 9 is 9/100 plus the third 9 is 9,000 plus the fourth 9 is 9/10,000 plus ... out to infinity. Our formula for the summation is the infinite sum is equal to n sub 1 divided by 1 minus r. 9/10 is n sub 1. Divided by 1 minus r. So what is r? What do I multiply this number to get there? Times 1. What do I multiply 100 by to get 1,000? Times 10. Times 1. times 10. So each iteration I'm multiplying by 1/10. That's r. So r is equal to 1/10. So let's do some arithmetic. So this becomes 9/10 divided by, I'm going to transform this 1 into 10/10. And 10/10 minus 1/10 is 9/10. And we could stop here because anything divided by itself is equal to 1. But if you wanted to continue, you'd say 9/10 divided by 9/10 is the same as 9/10 times 10/9. And now the 10s cancel, the 9s cancel, and you get 1. 0.9 repeating is equal to 1.